Welcome to the Camera Craft Workshop. Through the next series of videos, we'll be covering the very basic understanding and operation of a digital single lens reflex or SLR camera. Essentially, a digital SLR camera gives you a very broad range of control over the way the image is captured and exposed. The versatility and interchangeability of the system provides a great deal of scope above and beyond what is available on most compact cameras and camera phones. Though most digital SLR cameras are packed with dials and features, and each camera brand and model are set up in slightly different ways, there are three main elements common to all digital SLR cameras that control exposure. These three main elements are ISO, shutter speed, and the aperture. Each of these elements control the way light reaches the sensor in different ways, and the interplay of the functionality of these elements, along with the optics of the camera, offers a wide range of shooting strategies. ISO is a standard that relates to the sensitivity of the camera's sensor. ISO used to govern the light sensitivity of film. A film with high sensitivity would react to light quicker, which meant if you wanted to shoot fast-moving objects or people, or shoot in low light, then you would choose a film with a higher ISO or ASA rating. With chemical cameras, this would mean that once you have loaded the film for your shooting strategy, you would be more or less stuck with the same strategy until you finished the roll of film. With digital technology and sensors, the ISO or light sensitivity of the sensor can be adjusted for every picture. This provides digital photographers a lot more flexibility. ISO ratings and steps are more or less common amongst all digital SLR cameras, stepping up in a scale from 100, sometimes starting at 50, to 200, 400, 800, and so on. The higher the number, the more sensitive the sensor is to light. Higher or faster sensitivity comes at a price, because the higher or faster you set the ISO, the more noise will be present in your image. Therefore, higher ISO settings result in grainier and more noisy images. Shutter speed relates to how long the sensor is exposed to light. For fast-moving objects and people, you want a fast shutter speed to capture light in an instant. The drawback with this is that the faster the shutter is set, the less light reaches the sensor. This may result in underexposed images. To compensate, you will need to adjust the other settings that determine exposure, such as the sensor ISO and the aperture, to regulate the amount of light relative to the duration that the shutter is open. In low light conditions, you will often need to keep the shutter open for a long time. For very long exposures, the issue becomes about holding the camera still enough to prevent camera shake. With very long exposures, the use of a tripod is recommended. For most digital SLR cameras, a shutter speed anything slower than 1/40th of a second will need to be shot using a tripod. The final element controlling the amount of light reaching the sensor is the aperture. The aperture is opened and closed in set increments called f-stops. The maximum and minimum aperture openings is relative to the type and quality of the lens that you are using. Variable or zoom lenses in particular tend to have a narrower f-stop range than a fixed focal length lens. Understanding how the f-stop number relates to the amount of opening is tricky, as the larger the f-stop number relates to a smaller aperture opening. A high f-stop number of say f25 relates to a small aperture opening, whereas a low f-stop number, say f4, means that we have opened the aperture almost to its maximum opening. The main constraint governing the adjustment of the aperture is its relation with the lens optics. An open aperture is subject to a much shallower depth of field. This is the effect where the background or foreground is slightly out of focus. When taking portraits or close-ups, this is often desired, but when taking images of your architectural models or of buildings, then we really want all of the parts of the scene to be in focus. To ensure that you have the longest depth of field possible, you need to use an aperture with a small opening or a large f-stop number. Each digital SLR camera works differently. The main mode dials have a full automatic function. When used fully automatically, the camera makes all the decisions and balances and evens the interaction between ISO, shutter and aperture. To get specific effects and to leverage the different variability of the elements of exposure, you need to select either one of the priority modes or a full manual mode. Priority modes are usually represented by different pictograms, such as portraits, sports, landscapes, and so on. For example, in sport mode, the camera will give priority to shutter speed, so you just have to worry about the shutter response to capture movement, and the camera will adjust the other settings to suit. It is only in full manual mode that you are in control. In manual mode, represented by an M on the dial in this instance, the exposure dial adjusts the shutter speed. However, you can also adjust the aperture by toggling the dial with a secondary button. ISO or sensor response is usually set through the camera's menu options or a separate button on the back of the camera. It is worth noting that the normal operation of a digital SLR camera is different to compact cameras and camera phones in that you need to compose the image by looking through the viewfinder. Some digital SLR cameras allow you to preview the image on the rear screen by way of a lever that lifts the mirror temporarily out of the way. However, the ergonomics of the camera design makes using this function difficult and useful only if you're using a tripod. All settings and readings can be seen and adjusted when looking through the viewfinder. Because every camera is different, these instructionals will not go into detail about how to navigate the controls of a specific camera, and it will be easier to learn this once you have the camera in your hand. The combination of the three elements to capture light need to be calibrated in a way to ensure enough light reaches the sensor. If there is not enough light, then the image will be underexposed. Even when using the camera with manual settings, there are indicators on the screen inside the viewfinder that tell you whether an image is under or overexposed. The way the indicators work is different between camera types, but essentially all digital SLR cameras will have a sliding scale that moves left to right from a center point. The aim is to get the settings to balance so that the exposure indicators remain in the center of the dial. In this instance, we have used quite a small aperture and a reasonably slow shutter speed and a medium ISO setting. The available light in the room was quite low, and this has resulted in an underexposed image. Changing the settings from the underexposed image, the aim was to increase the amount of light hitting the sensor. In this instance, we slowed the shutter speed down and opened the aperture to its full extent. This combination of settings has resulted in an overexposed image. That is, too much light is hitting the sensor. Finding the right balance can be tricky sometimes. Other ways of increasing the amount of light hitting the sensor is to add more light to the scene by adding more studio lights focused onto the object or using a flash. When taking images of a building, timing the daylight has perhaps the greatest bearing on the quality of the end result. Professional photographers will study the way light tracks onto a building they are to photograph and will time their sessions in the field to align with the optimum daylight. It may also mean waiting long times to get the right shots around the building at different times of the day. To address the problem of overexposure, we have employed an ISO strategy, that is, to adjust the sensor's sensitivity to the light to find the correct balance. We have reduced the ISO down to 100, which has resulted in a properly exposed image. One would try and aim for a low ISO if you wanted to avoid as much noise in the image as possible. For objects and buildings that do not move, a low ISO strategy is usually a good choice to maximize image clarity. One thing to note here though is not all of the image is in focus. The reason is that we have kept the aperture open to the maximum, and this in turn reduces the focal depth or depth of field. Though the top of the cube is in focus, the bottom of the cube and the table it sits on are out of focus. To maintain the correct exposure whilst trying to maximize the depth of field and ensure that all parts of the image are in focus, we need to adjust down the aperture. Closing down the aperture to the smallest setting will maximize our depth of field, but at the same time reduce the amount of light hitting the sensor significantly. To maximize the clarity and avoid noise, we also ideally need to keep the ISO at a low figure. The only remaining variable is to adjust the shutter, which we will need to slow down significantly in order to allow as much light or as much light as necessary onto the sensor. At such a slow shutter speed, the camera must be on a tripod to keep it stable. The result here is a good exposure plus full focus. This strategy is the one most commonly used when taking images of your models. The great thing about taking photos of models and buildings is that they don't tend to move, so long exposures are quite okay. With fast-moving objects, the aim is to reduce the time of exposure as much as possible to capture that movement. This means we tend to open up the aperture and increase the ISO so that as much light as possible is introduced into the mix. In this instance, the swinging cube was not captured in time as the shutter was still too slow to capture the instant, and instead we see the moving object as a blur. In some instances, this effect is designed to capture the essence of movement and speed. To freeze motion, we need to further reduce the exposure time. Because the aperture was already fully open, the only option was to increase the ISO. At 1:250th of a second, the motion is frozen. However, at such a high ISO setting, at 3200, the amount of noise and graininess in the image is significant. The other strategy to capturing movement is introducing more light or using a flash to freeze motion. So in summary, you can see by this composite of the four images that the effects of the settings can result in quite different images. Understanding the effects of the strategies and predicting the outcome as a result of your camera setting takes some time. Using a digital SLR camera provides a high level of control we cannot achieve with most compact cameras and camera phones, despite the limitations of their bulk and complexity.